Hi Year 4, it's Miss Dunn again and it's time for our numeracy lesson today. So online learning packs ready please, and don't forget to use the pause button whenever you want for as long as you want. Let's go.
Right then, let's get those numeracy brains nice and warm. On the screen you'll see I've got two classic calculations, if you like. I've got 15 times 3 equals and I've got 18 times 5 equals. Underneath each calculation I've got room for 3 number multiplication calculations. So what I would like you to do is draw on your knowledge of the last two numeracy lessons. I would like you to separate out the 15 and the 18 into two separate factors, and then I would like you to multiply the three factors using your knowledge of 3 number multiplication. See how you get on. How did you get on? Hopefully you had a good go. Let's see then. So 15, what are the factors of 15? I chose that one first as it's a little bit easier because apart from 1 and 15, which wouldn't do us any good, there are only two other factors, and they are 5 and 3. Whichever way round you write them is absolutely fine, because 5 times 3 or 3 times 5 equal 15, don't they? And then we're going to multiply those by 3. So 3 times 3, I'm going to take it this way round, because remember you can do the calculation any way round that you want to. 3 times 3 is 9. 9 times, oh, I've used the wrong symbol, 9 times 5, because we're all really good at our times tables. 9 times 5 is 45. So 15 times 5, 15 times 3 is 45. And let me show you that as an addition calculation. So 15 times 3, there's 3 lots of 15, added together is 5, add 5 is 10, and 5 is another 5. And I'm exchanging 10 ones for a 10, and 10, 20, 30, 45, just to prove that it does work. Now 18 times 5, you could have actually factorised, that's what we call it when we're splitting the number into its factors, in different ways, because there are different ways of making 18. You might have said 6 times 3, you might have said 9 times 2. So I will do it both ways, okay? I'll come over here to do it. So we would have 6 times 3 times 5. And I'm going to do that multiplication first. 6 times 5 is, excuse me, 30. And then 30 times 3 is 90. And we'll just check that it works the other way round. So the other way round would have been, let me just roll the board up a little bit, 9 times 2 times 5. And again, actually let me write it the other way round. I'm going to do it the other way round. Let's do 2 times 9 times 5. So I'm going to do this bit first. 9 times 5 is 45. And then 45 times 2. 2 lots of 5 is 10. Exchange 10 ones for 1, 10. 40 times 2 is 80. Add 10 is 90. Okay? How did you get on? If you're not quite sure, go back and have another look. Here we go then to today's target. We are going to explore efficient methods of multiplication. Now, you may remember we've used the word efficient quite a lot when talking about addition and subtraction calculations. When we are trying to work efficiently, we're trying, quite frankly, to do the least amount of work possible. Okay, we're trying to make something very simple for ourselves so that it makes it easy for us to do the least amount of work and the least amount of writing. Okay, so it's only fair that we do that with multiplication, because we've already done it with the other two operations. And we're going to do that by partitioning or factorising numbers. What? Mister, what are you talking about? We all know what partitioning means. Separating the number out. Maybe we might do it into its tens and its ones, its hundreds, tens and ones. There are many, many different ways. Factorising numbers just means breaking them down like we did yesterday into pairs of factors. So 10 would factorise into 2 times 5. We're going to rewrite the calculations, remembering that associative law, So we can swap the numbers around within the calculation and it will still come out the same. I'll prove that to you later. Then we're going to multiply all of those factors together, and then we're going to add together products to find a final product. Are you ready to get started? Let's go. So the numbers that we're multiplying are going to get bigger, all right, fair warning. But I'm going to prove to you that it's really easy to multiply double digits by single digits by making the numbers work for us. So the first calculation that we're going to look at is 25 times 8 equals. Let's get stuck in. Here we go then, 25 times 8. There are different ways that we can do it, which is good because everybody's brain works differently and we all find easier ways different to others. So over here on the right you can see a picture and you can see it's in two different colours. That's because I'm trying to show you how we're going to partition our number first. Over here in the red array I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I've got 20 columns in my red array and 1, 2, 3, 4, 5 columns in my blue array. So what do you think I'm going to do first? I'm going to rewrite 25 times 8 into two different calculations, okay? I'm going to have a 20 times 8 and I'm going to have a 5 times 8. Okay, so I'm going to complete each side separately, then I'm going to add them all together. Are you ready? 20 times 8, you can use the picture if you want to. Let me put the picture back on full, okay? But we don't need to, do we? Because we know how to multiply in multiples of 10. So let's go back to what we did a couple of weeks ago. What's 20 times 8? Well, we know what 2 times 8 is. 2 times 8 is 16. And then we pop in the placeholder. So we've got 160, and to that we're going to add 5 times 8, which is absolutely 40. And when we recombine that, we get 200. How easy was that? Now you might want to look at it a different way. So here I have a different picture, and you can see I've got 5 different sets of colours. And in each set of colours I've got 1, 2, 3, 4, 5 columns of 8 rows. What do you think my calculation is going to be this time? So I'm going to have 5 times 8, and then I'm going to multiply that by 5. So this time I've factorised my 25. Let me rewrite this a different way. So I can show you that I've factorised my 25, and then I'll show you how I move it around. So 25 can also be written as 5 times 5, can't it? So that's me factorising the 25, breaking it down into its factors. And then we can multiply that 5 times 5 by 8. But I don't like multiplying by 8. It's far more difficult than multiplying by 5. So I'm going to swap that calculation around using that associative law. And I'm going to write my calculation as 8 times 5 times 5, because we know our 5 times table. So in our 5 times table, 8 times 5 equals 40. And 40 times 5, ooh, head scratching, but no it isn't. Because what's 5 times 4? It's 20, isn't it? And then we are going to pop in a placeholder. Okay, so 8 times 5 times 5 is 200, which is lucky because that's exactly the same answer that we got to 25 times 8 when we did it partitioning method. Okay, are we happy with those? Now let's have a go at 28 times 3. But before I have a go, why don't you see what you would partition that calculation into, but also see if you can factorise that calculation to make it a 3-number multiplication. What do you think? Okay, so 28 times 3, let's do the partitioning method first, and you can see that I've put a little picture on the screen to help you. So all we're doing is we're just going to separate 28 into its tens number and its ones number, and we're going to multiply, I can't speak today, multiply each one of those new numbers by 3 and then put them back together. So 20 times 3 seems easy, doesn't it? 2 times 3 is easy. It's 6, isn't it? And then to multiply by 10, we pop in the placeholder. I can almost hear you saying that with me now. I'm really looking forward to us getting back to school because we'll all be saying pop in the placeholders together. It really is the little things. And then 8 times 3 is 24, and then we can recombine them to give us 84. Okay, let's see how we did with partitioning. Now, I purposely did choose a number that's quite tricky. We do need to know our times tables for this one. 28 factorizes, because we're factorizing this time, to 7 times 4, or 4 times 7, whichever way around you want to do it. And then we multiply that by 3. In fact, I'm going to swap that around. I'm going to swap that around to 7 times 3 times 4, because I'm better with my 3 times table, and probably quite a few of you are as well. 7 times 3 is 21, and 21 times 4, let's start with the ones number. 4 times 1 is 4, 4 times 2 is 8, and the 8's in the tens column, so it becomes 80. Gives us 84. Let's just double check that our answers agree. 28 times 3 does in fact have a product of 84, whichever calculation you perform. How did you do with that one? It's your turn to have a go, and then we'll come back together and look at it together. And I would like you to try it both ways, please, just like I've been doing on the board. So 35 times 2 equals. I'd like you to use the partitioning method, where you partition the 35 and multiply each side before recombining. And then I would like you to try the factorizing method. What are the factors of 35, and then multiply those all together in a 3-number multiplication. And then when you're ready, we'll come back together and see how you got on. How did you get on? Let's have a look together then, shall we? So we'll do partitioning first. So 35 partitions into 30 and 5. So then we have 30 times 2, and we have 5 times 2. 30 times 2 is 60, because 3 times 2 is 6, and we pop in the placeholder, and 5 times 2 is 10. We put those two together and we have 70. Let's just check using the factorizing method. What are the factors of 35? 7 times 5. So I'm rewriting this calculation as 7 times 5 times 2. Okay, but I'm actually going to do it as 7 times 2 times 5. I'm going to use the associative law. I'm swapping my numbers over because I know my 2 times table far better. 7 times 2 is 14. 14 times 5 equals 4 times 5 is 20. Oops, what an awful zero, Miss Dunn. Let me redo that. And 5 times 10 is 50. Add 2 tens, 60. Oof, 70. So both methods come back to the same solution. How did you do? At this stage, don't worry if something went a bit wrong, something went a bit awry. Don't forget you can use your times tables posters. That's what I had you make them for, so you've got some resources at home, okay, so that you can look for factors. Don't expect you to do them off the top of your head at this stage. Some of you can, because some of you are more secure in your times tables than others. And if something's not quite right, just take the time to pause the video and check your workings out against mine and see what went wrong. The numbers are getting bigger, but don't panic. Just follow exactly the same processes. Partition the number and then do the multiplications. and then factorise the number and do those multiplications, and you should come back to the same product, and we'll look at it together when you're ready. Let's see how you got on with that one then. 42 times 5. So first we're going to partition. So we've got 4 tens and we've got 2 ones, and then we're going to turn those into two calculations. 40 times 5 and a 2 times 5. Okay, so 40 times 5, 4 times 5 is 20, and then we pop in a placeholder, and 2 times 5 is 10, and then we add those together to give us 210. How did you do with that? Okay, and then I'm just going to clear the board off and we will do the factorising method. Here we go. So factors of 42 are 6 and 7. So the factorised calculation should look like that. 6 times 7 times 5 equals. I'm going to have a little rearrange. I'm going to do 7 times 5 first, and then I'm going to multiply it by 6. So 7 times 5 is 35, and then I'm going to do 35 times 6. Okay, I'll start with the ones number. 5 times 6 is 30. 6 times 5, remember, you can turn it around, is 30. 30 times 6, what's 3 times 6? That's 18, isn't it? So we pop in a placeholder, which would make it 180. And then we can add those two together. 8 tens add 3 tens is 11 tens. We exchange 10 tens for 100, and that gives us 210, which is happily the same product as the partitioning method. How did you do? Hopefully feeling a little bit more confident, probably more confident with the partitioning method than with the factorising method, which is to be expected, especially if you're not too confident with your times tables, but we will keep persisting, won't we? If something went wrong, just rewind the video or keep the calculations that I've got on the screen and have a look at it. Here we go then, it's time for the independent working section of the lesson. There are 6 calculations on the screen. I would like you to complete each one following the partitioning method and also following the factorising method, please. Don't forget you can rearrange the numbers within the calculation to suit yourself and make it easier, because practice does make perfect, especially with something like this. And don't forget, if you've got them, you can use the posters that you've made to help you. Hopefully the more that you did, the easier they became. So let's have a look. 15 times 5, so we're going to have a 10 times 5, we're going to have a 5 times 5, and then we're going to add them together. So 10 times 5 is 50, 5 times 5 is 25, and when we put those together, we have 75. And then to factorise those, we're going to have 5 times 3 times 5. So 5 times 3, actually I'm going to swap that around to 5 times 5 times 3. 5 times 5 is 25. 25 times 3 is, 5 times 3 is 15. 20 times 3 is 60, and 10 is 75. Woo! Same answer, excuse me, same product with both. I'll leave that on the screen for you for a few seconds so that you can check yours, and then we'll move on. Here we go then, 22 times 4. So to partition that, we are doing 20 times 4 and 2 times 4. 20 times 4 is 80, because 2 times 4 is 8. Oh, we've done the whole calculation all in one go, look at that. So hopefully factorising it's going to bring us back to 88. 22, to factorise we have 11 times 2, and then we're going to multiply that by 4. Just going to swap that around to make it a little bit easier for myself. I'm going to do the 11 times 4 first, and then I'm going to multiply it by 2. 11 times 4 is 44. 44 times 2 is, whoops, Oh, Miss Dunn, that is seriously ropey. It's because I've just pulled the webcam and I've just got to the end of my webcam lead, which made the camera jolt a little bit and then made my pen jolt in my other hand. So 44 times 2 is 88 using both methods. Okay, I'll leave that again for a few seconds. You can check you're working. Hopefully everybody's giving themselves big ticks. And then we'll move on to the next one. Okay, 24 times 8. Thought we'd throw some multiplying by 8 in there. Now you could do this a few ways, but we'll do the partitioning first. But when you come to factorising, there are different ways to factorise it. So we've got a 20 times 8 and we've got a 4 times 8. Sorry, I was jumping ahead of myself again. I'm getting all excited. 20 times 8 is 160. 4 times 8 is 32. We add those together and we should come back to 192. So 24 we can factorise as 12 times 2. We could factorise it as 6 times 4. Or we could factorise it as 8 times 3. Have I got to do all three? Oh, I didn't think that one through, did I? Right, let's do them all then. So 12 times 2 times 8, 6 times 4 times 8, and 8 times 3 times 8. I can see we're going to have a very long board ahead of us. So before I roll the board up, just have a look at the first method and check your working and your answers on that one. Hopefully you've all given yourself a big tick. Right, I'm just going to roll the board down then so that we can crack on with these. So 12 times 2 times 8. 12 times 8. It's a nice simple one. Because for some reason all of the ends of the times tables stick in my head. So 12 times 8 is 96. 96 times 2. A little bit more tricky. 6 times 2 though is 12. So I've got a 2 here. And then I've got 1 10 in my tens column. 9 times 2 is 18. So 90 times 2 is going to be 180. So I've got my 100, and then I've got 90. Oh, good. 192. Has that come back to, whoops. Has that come back to the right number? Absolutely. Right, let's check 6 times 4 times 8 then. I'm just going to rub those arms out. And while I'm doing that, if you chose to do the 12 times 2, you can check your working. So then we've got 6 times 4 times 8, which I think I'm going to rewrite as 8 times 4 times 6, actually. Because I know that 8 times 4 is 32, okay, and then I can do 32 times 6, 6 times 2 is 12, and exchanging 10 ones for a 10, 6 times 3 is 18, plus the 10, 192. So far so good. On to method 3. Oh, I'll press the button this time, sorry, let me just roll that back down if that's the method that you chose, okay. And then 8 times 3 times 8, I'm going to start with 8 times 8. And then I'm going to multiply it by 3. Because I know that 8 times 8 is 64. And then I'm going to multiply that by 3. So 4 times 3 is 12. I haven't left myself enough room, I've just realised. 6 times 3 is 18, so 60 times 3 is 180. So, oh, fantastic. I must be doing something right because they've all come back to 192. There you go. Let me see if we can squeeze them all onto the one screen, actually. Just about, actually. There you go. It would have just been, I would have had no back left if I'd done them down there. So they're all on the screen. You can double check your working and hopefully give yourselves some big ticks. And then we'll move on to 33 times 6. 33, how does that partition? It partitions into a 30 and a 3. We're going to multiply them both by 6. 30 times 6 is 180, because 3 times 6 is 18. And then we add those together, which should give us 198. Then if we factorise it, let me just roll the board down again. That would be 11 times 3 times 6. I'm going to swap that around to 11 times 6 times 3. 11 times 6 is 66, and 66 times 3. 3 times 3 is 18, so 8 there, that there, and 198. Does that agree? It does! There we go. There are both methods on the screen. so that you can check your working and hopefully give yourself some big ticks. And on to the next one, which is 45 times 2. We can partition into 40 and 5, multiply both sides by 2. 4 times 2 is 8, so 40 times 2 is 80, and 5 times 2 is 10. Add those together gives us 90. Now factorising, how do we factorise 45? It is in fact 9 times 5 or 5 times 9. 9 times 5 times 2. I'm going to do it this way. I'm going to do 5 times 2 and then I'm going to multiply those by 9. Multiplying by 9, Miss Dunn, are you mad? Well, yes I am, but not for this reason. Because what's 5 times 2? Exactly. And we know our 10 times table really well, so I probably don't even have to do any working out to know that 10 times 9 is 90. Okay, so there's both sets of working. Give yourselves a big tick, hopefully. I've truly lost count of how many we've done. I think this is the last one. Let me just check. Yes, it is. Okay. 54 times 5. Let's partition it first. There we go. We've got 50 times 5 and we've got 4 times 5. 50 times 5. So we've got to, oops, no, we've not got to pop in a 6, Miss Dunn. We've got to pop in a placeholder. And then 5 times 5 is 25. There we go. And 4 times 5 is 20. We add those together, gives us 270. Then, what are the factors of 54? They are, in fact, 6 and 9. Okay, and we know that because before, 5 times 9 was 45, and 54 is the next product up in our times table. We always use what we know. So 6 times 9 times 5 is going to be my next calculation. So I think, looking at those numbers, I'm going to do 6 times 5 and then I'm going to multiply it by 9. You might have chosen to do it a completely different way, which is absolutely fine. I know that 6 times 5 is 30. 30 times 9, 0 times 9 is 0, isn't it? 3 times 9, 9, 18, 27. Oh, phew, I got the same response for both. 270. Let me just roll the board up. Whoops. And you can have a look. Hopefully give yourself a really big tick for the final one of our independent work. That seems like a really good place to stop, have a quick reflect and think about what we've learned so far. Thinking about today's target, which was to explore efficient methods of multiplication, continuing that theme of making the numbers work for us because we are not their slaves. Okay, so our success criteria were to partition or factorise numbers, rewrite the calculation in a way that we can work with it easier, multiply each of the pairs of factors if we had pairs, or complete the 3-number multiplication, add the products together to give us the final product. So how confident do you feel with that at this particular moment in time? Are you grinning like a Cheshire cat because you've got it, you've nailed it, you're really super happy with it? Are you somewhere in the middle? Not too sure. It could be that you're happier with partitioning than you are with factorising, and that probably is the same for most of you, I would suggest, at this moment in time. Some of you will be happy with factorising because you're really, really secure with your times tables. And if the more that we know about our times tables, the faster it will become to factorise those numbers and multiply them. So most of you will probably be in the middle category, I would suggest, because we're happier with partitioning than we are with factorising. But hopefully not too many people have got grouchy faces because they're not very happy with their success at today's learning objective. But take a moment and think about it, because it is always worth reflecting. It's challenge time. Now don't panic. when you look at the number that's on the screen. I want you to think about and write down how you would calculate 228 times 5 using the methods that we've learnt today. How did you get on with my challenge? Did you partition? Did you try to factorise? Hopefully you partitioned, because not even I can figure out what the factors of 228 are. I probably could, given the time, if I had the time and energy to do it, but I'm going to partition the number into the hundreds, the tens and the ones, and that way I could multiply it quite easily, because we know how to multiply by 100, don't we? We do 2 times 5, which we all know is 10, and then we pop in the placeholders. With 20, we do 2 times 5, which we know is 10, and we just pop in the 1 placeholder. And then 8 times 5, forgot my equal sign, is 40, 1,140. So from that really scary number at the very beginning, that's what we end up with, including a couple of very ropey zeros, Miss Dunn. 1,140. How did you do? Hopefully really well. Final recap then. Hopefully, if there were any grumpy faces, that's helped to move you at least to the straight face or to the slightly smiley face. So at the bottom of your work, draw the emoji that best reflects how you feel about that lesson. That brings another numeracy lesson to a close, and that means we are another numeracy lesson closer to being back in the classroom together. So until then, please remember to WhatsApp, email, or to drop some work into the post box when you're out on your daily exercise, because I love to see it and I will send you some feedback by email. So until our next lesson, take care of yourselves and I will see you soon.